Hello everyone. In our home, at few places we install the bulb and at few other places we install the tube light. How we decide that? If you have any idea about it, let me know in the comment box. And if you don't know, you'll discover the brilliant answer in this video. Okay. The bulb can be considered as a point source and the tube light can be considered as a line source or the linear source. The formula for the intensity of the electromagnetic waves we have seen in the previous video. So utilizing that formula, I'll be answering the things. Let's start with the point source, the bulb. For example, suppose we consider a bulb here. This bulb will radiate energy in all directions. If you consider a bulb here, it will radiate the light, the electromagnetic waves in all direction. Okay. Here we consider a sphere of radius r. The formula for the intensity is already known to us. The intensity is equal to power divided by area. So at any point of this sphere, if you want to obtain the intensity, then you can use this formula. Area of the sphere will be equal to 4 pi r square, and let's say the power of this point source we consider as P. Okay, what is P here? The power of point source. Now, in the previous video we have seen for electromagnetic waves the expression of the intensity was 1 by 2 epsilon naught E naught square C, or there was another expression which was equal to B naught square C divided by 2 mu naught. So if we look at the things, we can relate few parameters. Number one, the B naught is proportional to 1 by R. Let's write it here. Similarly, the E naught is also proportional to 1 by R. The intensity itself, if we indicate it with I, then I is proportional to 1 by R square. Do you agree? Again, taking up the point source and we consider the distance R. Here the intensity is, let's say, I naught. And the amplitude of the electric field we indicate by E naught. In EM wave, the electric field and magnetic field will be perpendicular to each other. So the oscillations of the magnetic field will be in this direction. Okay, I cannot show that here on the 2D board, so I'll show it like this. Now instead of the distance R, we consider the distance 2R. Look at this relation. If distance is made twice, then the intensity will become 1/4. So here the intensity is I naught by 4. And if the distance is made twice, then the amplitude of electric field and the magnetic field will become half. Do you agree? So at this location here, the amplitude of the electric field is half of the previous one. So we write it as E naught by 2, as well as the amplitude of the magnetic field also becomes half. So let's say we write this as B naught by 2. Okay. Blue color we are using for the electric field's amplitude. Red color we are using for the magnetic field's amplitude. Now, suppose we consider the next distance, the 3R. From this point source, we are at a distance 3R away. At a distance 3R, the intensity will be how much? I naught by 9. I hope you understand it. If you put here the factor of 3. So intensity becomes I naught by 9. And at a distance 3R, the amplitude of the electric field and magnetic field will be respectively E naught by 3 and B naught by 3. As the wave is propagating, the same power is distributed over a larger area. I hope you get this. If the point source is here and you consider the sphere, the power is distributed in this sphere, and then if you go at a distance 2r away, 3r away, the radius of sphere is increasing. So the same power is distributed over a larger and larger sphere. So intensity will keep on decreasing. Power is constant for the source, and as the wave is propagating, the area of the sphere will keep on increasing. So the intensity will keep on decreasing. Got it? Now, what are the practical applications of these things? Where you need the intensity to fall rapidly, you will be installing a point source, means you will be installing a bulb. For example, you have seen the reading lamps in the flight or in the train. How do they look like? A line source or a point source? Actually, they look like as a point source. As the R will increase, the intensity will decrease. Got it? Another example of the point source. In your mobile, there is one LED notification light. How that look like? A point source or a line source? Again, the answer is point source. Suppose outside your home, you want to install some source of light. So in the evening, there is sufficient light in front of your home. Let's say this is the door. What you install? A bulb or tube light. And here is your friend's home. You two are neighbors and good friends. So being a good friend, what you'll be installing here? A bulb or tube light? Let me know in the comment box. Usually people install a bulb here. So that bulb will illuminate the area in front of your house. Got it? The same your friend does. Your friend also installs a bulb here, and intensity falls with this relation 1 by R square. Okay. So this is about the point sources. Same kind of analogy is true in the case of sound waves also. Sound waves are although not the electromagnetic waves, but the same kind of analogy we can see there. I'll explain that in the video of the sound waves. Just let me ask you one question related to that. Suppose some students want to cheat in the examination hall. How do they ask the question to the fellow students? Do they put the hand around their mouth and try to make it as a point source, or they shout like anything? You have practical experience of this thing. Usually, in order to cheat, student puts the hand around the mouth like this. The student tries to make the mouth as a point source. So the intensity should fall rapidly as the distance increases. So the sound waves intensity as it travels away and away should decrease, and it should not be audible to the examiner. Got it? You note down all these informations, and then we'll proceed for the line source, the tube light, and then we'll be comparing the point source and the line source. Okay. Now let us consider a line source. The power of the line source is P, and it is radiating the energy in all directions. Suppose this is a line source and it is radiating energy in all directions. So the wave fronts will be actually cylindrical. I hope you understand this. At a distance r, we consider a cylinder of length L, and we write the expression of the intensity here. Intensity will be equal to power divided by area. Area of this cylinder will be 2 pi r L. Okay. How we obtained that area? You take this cylindrical surface like as a piece of paper, and you unfold that cylinder. When you unfold the cylinder, this length will be 2 pi r. Cut the cylinder, unfold it. This height is L, so the area will be equal to 2 pi r L. Okay. Now, the intensity of the electromagnetic waves can be written as 1 by 2 epsilon naught E naught square C, or the same intensity can be written as B naught square C divided by 2 mu naught is equal to P by 2 pi R L. As we did on the previous screen, we can relate the parameters. B naught is proportional to 1 by root R. E naught is also proportional to 1 by root R. Do you agree? And the intensity is proportional to 1 by R. These are the important relations. Now I am making another diagram. We go at a distance R away. The intensity is I naught here, let's say. Then the amplitude of the electric field is E naught. The amplitude of the magnetic field is B naught. At a distance 2R, what will happen? Can you pause the video and let me know? At a distance 2R, if the distance becomes twice, intensity will become half. So here intensity is I naught by 2. The amplitude of the electric field will become E naught by root 2 here at this location. Same happens with the magnetic field. The amplitude becomes B naught by root 2. Do you agree? At a distance 3R from the source, radial distance 3R, what will happen? Intensity will become I naught by 3. Correct. Absolutely correct. And the amplitude of the electric field will become E naught by root 3. And the amplitude of the magnetic field will become B naught by root 3. You get this? As the wave propagates, same amount of power P is distributed over the larger surface area, so the intensity keeps on reducing. Now, in your study room, you will install a tube light or a bulb. You can give the answer very easily. I'll show the point source bulb here. For bulb at a distance R, if you remember the previous screen, intensity is I naught, then at a distance 2R, the intensity was I naught by 4, and at a distance 3R, the intensity was I naught by 9. If we compare a line source and a point source, bulb can be treated as a point source. Then at a distance 2R, at a distance 3R, you see the clear variation in the things. At a distance 3R away from the line source, intensity is 1 by 3, but here the intensity is 1 by 9. So on your study table, if you want to install some source of light, you should be installing a tube light, because at a greater distances, the tube light's intensity is better as compared to the intensity of the bulb. Got it? So in whatever application you require better intensity of light at the farther distances, you should choose the tube light over the bulb. Now I think you can explain that in this metro coach why the tube lights are installed. Have you ever observed that thing carefully? Answer lies here. For the linear source, the intensity falls by 1 by R. Here the intensity falls by 1 by R, but for point source the intensity falls by 1 by R square. So in the metro coaches we install the tube lights, and in the aeroplane, in the train, there are reading lamps. They are point sources, because the light coming from that reading lamp should be closer to the person who wants to read the book or something. Other passengers should not get disturbed. So the intensity should fall rapidly as the light goes away and away from the source. That's why they choose the point sources of the light. I hope you understand this thing. Okay. Another application. Look at the mobile towers. Why the structures are linear? I think you can answer it yourself. Look at the antenna of the walkie-talkie. Look at the antenna of the Wi-Fi router. Look at the dipole antenna. They all are linear. For linear sources, the intensity will fall by 1 by R. Got the advantage? So they can distribute the signals at a greater distances with the sufficient intensity as compared to the point source. Done? So this is the great comparison between the line source and a point source. I hope you understood the things. Now, can you give me few examples in your daily life where you have seen the line sources and the point sources and their particular applications? And for the line source, I can give you analogy with the sound waves also. Although in this video we are primarily focusing on the electromagnetic waves. In the cinema halls, in the DJ, or in the good home theater systems, the speakers are the line source or the point source. In home theater system, in the cinema halls, in the DJ, you want better intensity of the sound even at the far away distances. You choose the line source. In your home theater system, you have the sound bars. I hope now you understand the logic. Although the details of the sound waves and the intensity formulas will be taught separately in the video of the sound waves. Got it? I hope you enjoyed the information. Note it down. Stay awesome. See you again.